Okay, write the first four terms of each sequence given the formula. So the first one is t subscript n equals n squared plus 1. So if I want term 1, I'm just going to replace the n with a 1. So I'd have 1 squared plus 1. 1 squared is 1, so I had 1 plus 1, which is equal to 2. So term 1 is equal to 2. Term 2 in this sequence would equal the n, which is 2, 2 squared plus 1. So we get 4 plus 1, which is 5. And then term 3 would equal 3 squared plus 1, and then that would be a 9 plus 1, which is equal to 10. And then term 4 would equal 4 squared plus 1. That's 16 plus 1, which is 17. So the first four terms in this sequence would be 2, 5, 10, and 17. Okay, now because we're only writing the first four, I'm not putting the ellipsis after because I'm going to assume that it just stops after the first four terms. If it said, if it was more explicit, we could put the ellipsis there. I wouldn't mark as long as it had the ellipsis because it doesn't say whether it's finite or infinite here. Part B is in its function notation. We've got term n being equal to 2 to the n divided by 2 times n. So term 1 would equal 2 to the 1 divided by 2 times 1. And that would be a 2 divided by 2, which is just equal to 1. So the first term in that sequence is just a 1. Term 2 would equal 2 to the 2 divided by 2 times 2, which would equal 4 divided by 4. I went to my rubber stylus here and it just doesn't work as nicely as my other one, but it is much quieter, I'm sure, on your ears. Term 3 should equal 2 to the exponent 3, which is an 8, divided by 2 times 3, which is 6, and then 8 over 6 could reduce to 4/3. And then term 4, if I can squeeze that in here, term 4 would equal 2 to the exponent of 4, which is 16, divided by 2 times 2. Sorry, 2 times 4, not 2 times 2, which is an 8. So 16 divided by 8 would equal 2. So my first four terms of this sequence, let me just switch colors just so that it can stand out from all the other things that I have written in here because it's kind of tight for a room here. It would be 1, 1, 4/3, 2 would be my first four terms in that sequence. All right, part C is a recursive formula. So term 1 is given already. It's the seed value. It's defined as being equal to 5. Term 2 will equal 2 times the term before it. So it'll equal 2 times, I keep resizing this by accident here, sorry about that, 2 times t at 2 take away 1, which is really term 1, plus 3. You could have just put term 1 there, but I just want to be explicit about that so you understand what's going on. So I'm really taking 2 times term 1 plus 3. So term 1 had a value of 5, so term 1 was equal to 5, so 2 times 5 plus 3, we get 2 times 5 is 10, add 3 to that, that would be a 13 there. Okay, when I go to calculate term 3 here, I'm going to shorten that up a little bit because I'm running out of room. Term 3 would be equal to 2 times term 2 plus 3, and term 2 had a value of 13, so it's going to be 2 times 13, which is 26. 26 add 3 would be 29. And then term 4, I'll try and squeeze that in over here, term 4 would equal 2 times the term before it, which was term 3, plus 3, and term 3 had a value of 29, so 29 is its value. So 2 groups of 29, well that would be like 2 groups of 30, which is 60, but then take 2 away because I added in 2 extra values. So that should be a 58, but then add 3 more to that, should be a 61, I believe, if I've done that correctly. So that gives us our first four terms in this particular sequence are 5, 13, 29, and 61. All right, now the last one, it is a recursive function as well. I'm going to switch colors once again. I'm going to do that one and I'll do this in red. Term 1 and term 2 are already defined for us. Term 3, so my n value is 3 here, would be equal to term, and then I've got an n take away 1, so it would be 3 take away 1, which would be actually term 2. And then in brackets, whoops, that's not the way the brackets were. The brackets go around the next part, which is term. Doesn't really matter in the end. Term n take away 2. So my n is 3, so it'll be term 3 take away 2. All right, if I evaluate that, 3 take away 1 is really term 2. And then that multiplies term 3 take away 2 is 1. So I'm really multiplying the previous two terms together here. That's really what this little formula is saying right here. So term 2 was a 5, and term 1 had a value of 2. 2 times 5 is 10. So my third term has a value of 10. Now that we've done that one, I can go into term 4. Term 4, I know, is really just going to be the product of term 3 times term 2. And term 3, we just got to be a value of 10, and term 2 has a value of 5. So 10 times 5 is 50. So its first four terms of the sequence are 2, 5, 10, and 50. So hopefully that makes sense. Okay, question number 4. Determine the seventh term of the sequence based on the general term. So general terms are much easier to work with because you don't need the previous one. If I had a recursive formula and I needed term 7, it means I would need term 6. And to be able to get term 6, I would need to have term 5. And to be able to get term 5, I would need to have term 4 and all the way down to term 1. So there's a lot more work involved with recursive when you're trying to figure out terms further on in the sequence. The first four aren't bad, but if I wanted the 100th term, there's a lot of work to be done there. All right, so term 7 would be 3 times n, which n has a value of 7, take away 5. So that's really 21 take away 5, which is 16. Term 7 here would be 2 to the exponent of n, which is 7, and 2 to the exponent of 7. Ooh, it is 2 to the 7. That one is 256, I think. Get my calculator. No, it's only 128. I made a mistake. There we go, 128. And for part C, term 7, will equal 7. That's my n value. And then times 7 take away 1. So Bedma says inside the brackets first, please. 7 take away 1 is 6, and 7 times 6 is 42. All right, and question 5, determine the seventh term of the sequence based on the recursive formula. So this one is a little bit trickier. It's not quick like question 4 is, because with recursion, you got to actually get the term before it. So if I want term 7, so what I was saying earlier, to get term 7, I would take 2 times term 6, n minus 1 would be term 6, and then take away 3. But I don't have term 6 yet, so I would have to do term 6 is really equal to 2 times term 5, take away 3. Oh, but I don't have term 5 yet, so I really have to go term 5 would be equal to 2 times term 4, take away 3. And I don't have term 4 yet, so do you see what I'm saying here? This is a lot of extra work. Recursion sometimes is easier to figure out the formula for it, but it's not easier to work with it. So fiddlesticks on that one. All right, term 3 would be equal to 2 times term 2 minus 3. Term 2 is really equal to 2 times term 1 minus 3. Okay, so now we can work our way forward again. 2 times term 1 has a value of 5. Take away 3, that would be 10 take away 3, which is 7. Okay, so now that we have term 2, we can fill that in here. 2 times 7, take away 3, that would be 14, take away 3, that's 11. So now we can get term 4, 2 times 11, take away 3, that's 22, take away 3, should be a 19, I believe there. 2 times 19, that's 38. 38 take away 3 would be 35. 2 times 35 is 70. 70 take away 3 should be 67. And I really hope I haven't made any mistakes on this, because I'm like seriously just doing this in my head, and I'm not gonna lie, it might be midnight like during Christmas holidays, so you know, what else is there to do during Christmas holidays but to prepare wonderful lessons for my favorite students. All right, this one I'm going to use my calculator for. Hopefully I haven't made any mistakes on that. And I think it turns out to be 131. So my term 7, that's all that work just for one single term, is really equal to 131, I believe, if I've done that correctly. So hopefully that makes sense for you.